Hey guys, thanks for tuning into CMTEQ channel. So this is C programming, yes, for electrical engineers. I've attempted to do this a live tutorial, a live session. Unfortunately, my internet and also my computer is struggling to carry out a live streaming properly. So as a result, I'm losing some data packets as I'm trying to stream. So I will try again next time for another session, but I know I do need to upgrade my equipment. I need to upgrade my computer to a much newer CPU. So if there is anyone out there who would like to donate a good enough computer or laptop that is going to be extremely nice and appreciated, so that CMTEQ channel can perform the uploading and the live streaming of engineering content, electronics, electrical engineering, programming without interruption. All right, so hence I'm basically rather recording the session and then upload without fault. That's always work. Okay, so what I have here basically is an LM317. An LM317 typical application circuitry that I've wired onto the breadboard here. I've tried to explain it on a live session. So what you see here is my LM317, right? So that's pin 1, pin 2, pin 3 as it is specified here. So I have a resistor R2 that is wired between pin 2 and pin 1, and I've got a potentiometer here connected between pin 1 and the ground. All right, now this other resistor here, don't worry about it. This one is basically just powering this LED, okay, for indication that I've got an input voltage. So in case it's not working, I know I do have an input voltage, so I can start debugging somewhere else. So right now, if I excuse me, so right now if I probe it, you can see that I'm getting 14.33 on the input. I'm not sure if you are able to see there. So it's 14.33 volt, and my output here is 3.9, I believe. So if I swing my potentiometer right and to the lowest, I'm getting 1.4 volt on the output, and if I swing it back the other direction, then I'm getting an output variation that can go up to 13.54. okay, so this is assuming there is a voltage drop. Okay, there is a voltage drop of 1.25, which is a reference volt, okay, a reference voltage, and there is some voltage that will also be dropping across the R adjust, the potentiometer there, because according to the data sheet there is a current I adjust that is typically 50 microamps, so it's going to drop a little bit of voltage, not very significant, but yes. Okay, so it is working. As you can see, it is working. So I can just do any output I have, I wish to have. Okay, so if I'm powering a low power microcontroller that need 3.3 volt, I can set this thing to basically just output a 3.3 volt or 2 volt or a fixed 5 volt. As you can see there, I've got a fixed 5 volt. Okay, but now, as I've said already, this fixed 5 volt corresponds to a voltage, okay, to a resistance, I should say. The resistance is basically between the potentiometer, so it's a fixed value. in order to measure that resistance, excuse me, you have to disconnect your potentiometer, right? If I disconnect my potentiometer and then I probe across the ports here, and well, I have to change my multimeters to an ohmmeter scale, and we can see that I'm getting 640 ohm. Okay, let me just put it that way so that everyone can see what's going on here. Probe, right? So we can see that it is rather fluctuating because the connection is not good. I need a very good connection there so that we can measure it. It's a bit tight here. Okay, now I have it. So you can see that I've got 675 ohm. Okay, so that resistance value is fixed for an output voltage of about 5.2 volt. Okay, so when I put it back, okay, there was a swing. I did disturb it, so I have to change it again. So that it can have 5 volt. Right, so this is how the LM317 voltage regulator works. So you have an input voltage and the output can be regulated via the adjust, or you can put a fixed resistance and that will give you a fixed output voltage. Now the capacitors value here they are important for filtering, okay, on the input, and on the output they are important for stabilization, because you do not want your output voltage to be fluctuating if there is fluctuation on the input. So you want good stabilization, so that's why you're going to put a cap here, because they are chips like microcontrollers, MCUs, right? They want a stable input voltage, because if the input voltage drops below a certain point, it might reset, and you do not want that. So to provide that stabilization, these capacitors on the output are very good. All right, and the one thing to note is this is a linear regulator, right? Because it's linear, so the current on the input is exactly the same current on the output. So this means if you are drawing 1 amp at 5 volts, that's 5 watt. And if you're putting a 28 volt as the typical application suggests, that basically means you're dropping 23 volt. Now 23 volt times I, V times I, give you the power. That's 23 watt. So you burning 23 watt here, and which means your efficiency is what, 5 divided by 23. Okay, so 5, right, 5 watt divided by 23 watt. Well, look at it, you've got 21.7. okay, you have to make it times 100%. okay, so that is 21.7 efficiency. So 21% efficiency, that's bad. You really you can't cope with that. You're wasting, right? You're wasting. So what this means is to minimize the waste, right, or to at least get a good enough efficiency, your input voltage must not be very high if you are going to be scaling it down to a very low output voltage. So in other words, the difference between the input and the output must not be really more than 3-4 volt, otherwise you will have a bad efficiency. Okay, so now having said that, let's go into the business of the day, which is C programming for electrical engineers. So what we're going to do here is basically, instead of us battling with right, changing resistance values and trying to figure out what we want, now what we basically going to do in the C programming, you can just like say, okay, I want an output voltage of 3.3 volt. What will be the resistance, okay, that will be needed for that? Okay, so this design tool, this C programming application will basically empower you for that. So if you want 15 volt on your output, okay, and you have an input voltage that is like 20 volt, okay, then you say, okay, which resistance value, which value of R1 do I need in order to maintain 15 volt on my output? Then your C programming will basically enable you to have that. So you just enter the output voltage. So I need 15 volt. Boom, it gives you, well, R1 must be 20 ohm, 15k, whatever the value will be. So that is what we're going to achieve here. And also we're going to have also one option, okay, one option that will give you a fixed value regulator calculation, and another option will be adjustable. So the adjustable will basically mean you playing with the value of the potentiometer. So for every value of potentiometer, you know what will be the approximate output voltage that you're going to have. So that's basically what we're going to achieve here. But now we know what the problem statement is. So in order for you to perfectly execute your program, you need to have a set of rules that you need to follow, an algorithm, right? A program flow, design program flow that you must follow, and that way, you know, it will be much easier to debug your program if needs be, right? So we can say that a good algorithm is a set of rules that really tells you what your program is going to do. So I've got an algorithm in a form of a flow chart, right? So first the program will start, okay? So this is the start of the program, and when I start my program, obviously the program must load all the preprocessors, right? The variable declarations, then all of the things that I'm going to be using in my code. And then the next thing I need to do here, I need to display a menu, okay? We need this menu here, 1, 2, and X, okay? X is for exit program. So we're going to display that menu. And then the user must make a selection, okay? So because the user is going to be making a selection, then we need to read the user input, okay? So we're going to make use of the input, right? The input functions built-in library, so we can scan the user input. Now once we read the user input, we can then decide what to do with it, okay? So like we see here, X will be for exit program, so 1, 2 will be for specific calculation. So once the user enter a 1, right? If the user enter 1, here we are checking the selection. If the user enter 1, we come here. If selection is 1, then we need to handle what we need to do in 1. Now here we could have added the code, but obviously we know that in this block here we'll be dealing with the situation in selection 1. And if the user selects 2, we're going to be inside here. We'll be dealing with the situation involving selection of 2, right? Then we display the result. And if the user exit, right, rather select X, then we exit a program, right? We exit a program terminated. But if the user select an invalid result, right, an invalid selection, a selection that is not available here, okay, so what do? We must handle it, and we must return back to the menu, okay? So we're going to stay in a loop. This is a loop, right? This loop will continue so long as we don't hit the X and exit the loop, or we take a 1 or a 2 to display something. But even after displaying the result, we're going to come back into the menu. After displaying the result for selection 2, we're going to come back to the menu, okay? And we're going to repeat again the user selection reading. So this is how the program will work. Now if you design this very well, it will be now much easier for you to follow this flow chart while you're trying to execute your program design. So the first thing here, obviously we've done with the demonstration here, we can see what is going on here. okay, onto our breadboard and so forth. So now we need to start coding. Now I'm here on the main function, right? Main.c. First thing, I need to display my menu now, because I need to display the menu. And as the program algorithm here shows that every time we get a wrong selection or even executing a task, we will come back to the menu. Now, because we need to be coming back to the menu after after handling a user input, that basically means we need a kind of a loop, right? And that loop must only exit if the selection is equal to X. Okay, so that basically will mean we need a do while loop, right? It's going to execute while the user input is not equal to a certain value. So I'm going to call a do while loop. Do while what, right? We're going to say do while the user input is not equal to X, because if the user input is equal to X, that's when we're going to exit this program. So I'm going to say do while user input. Now the user input is going to be stored into a variable, so which means now is a good time for me to actually define or declare a variable that is going to be holding the user input. So I'm going to go ahead and declare my variable. So here is variable declaration. It's always important to write comment into your code. Now the variable will be of type character. We're going to make it that the user will enter a character, because we've got 1, 2 and X. We're gonna make them character, right? So variable of type character, and we're gonna call this variable select, okay, because the user is going to make a selection. Now we don't initialize it to anything, okay? Then inside here, right, inside the do while loop, then we need to assign the value into the variable select, and that value will be coming from where? It will be coming from the return variable that the menu is going to return, because the user is going to select on the menu. So the menu function, okay, so the menu function must return a variable, okay, based on the user selection. When the menu return a variable, then we're going to process it, okay. So while we're processing it, we're checking, okay, if that variable select, okay, is not equal to character X, then we're going to continue to execute. We will only quit if the user variable is equal to X, then this statement become basically false, right? So when the statement become false, then we've met our exit condition. Then we're going to exit the loop, okay? So we're gonna exit the loop, then we're going to return 0, and then the program will end, right? But if the user variable, user input, is not equal to X, then we will continue to execute our do while loop or handle the variable as they come. Okay, so now we have to basically, because the user is going to be entering character X, it could be a small letter or capital letter. Now, because we will not know which one the user will enter, so we basically just going to capitalize everything that the user is going to enter. So to do that, we're just going to pass the parameter select into a function called toUpper, right? So we're going to say toUpper variable select is not equal to X, then we do the deed, right? All right, now let's go back into the flowchart here. So we have started the program, we've declared variable. Now we come into the display menu option here. So I've created a function called menu, but the function do not exist. So I have to basically I need to create that function, and I need to define it because it's not defined anywhere. Because if I run the program right now, it's going to throw an error. That is obvious because the function menu does not exist. So now to do that, what I'm going to do, I'm going to create a new source file. Right, I can go ahead and define my main function in the same main.c here, which is okay, but because I want to make something that is a more easily manageable project, so you have to create source file for specific things that you are doing. So to do that, I'm gonna click here on the new file, right, and select file. When the pop-up shows up here, select C++ source file, okay, and then here just click next, and then you have to go where your project is saved, and in here you give the name for your source file. I'm going to name mine LM317, just like that, and then you click on save. Make sure you tick debug and release for compilation reasons. Okay, now we have a C source file for my library, and we have to also create a header file. So file again, and then C++ header file this time around. Next, and here you can basically just call it the same name, LM317, and you can just save it. It will be the .h file. Then you say finish. Now we have a header file. So what I'm going to do, I'm going to basically cut these C library files, okay, and I'm going to place it inside my header file here. Now because I've done that, I have to come back into the main.c here, okay, then I have to include my library file. So I'm gonna say include LM317, and you can see the library is already showing up here, so which means it is available. So now I have my library file in there. Now I'm gonna go back into my LM317.c and also include my library header file. Okay, so the header file need to also be included in here. There it is. There we go. So LM317. Now let's go ahead and create these famous menu functions. So the menu function is of type character. So menu. Okay, here is a function created. The function has nothing, it's a blank function. If I run it, there might still going to be an error because it's going to be an implicit declaration. Why? Because there is no function prototype. So I'm going to go into my header file here, just put a comment and say function prototype. And here I'm going to just create a function prototype for my menu. Okay. Now I'm gonna go back in here. Since the function prototype is done, now I can start populating the menu. But before I do that, I'm going to basically just create a description box for my function here, because it is important that you basically describe what you are doing, because if you do not describe what you are doing, then it is going to be very difficult for someone else to basically come and work on your project. Okay, so I'm just going to create a description box here, and inside this description box just put enough information for this function. So I'm gonna just say description. So what does this function do? Well, it display a menu. Okay, it display a menu. What else does this function do in terms of input parameters? Does it receive an input? No, the function is not going to receive an input, so we're going to just say none. So no input. In terms of output, what is going to happen? This function is going to return something. It's going to return the user selection. So that will be the output, user selection. Right. So now I can go ahead and start writing my famous menu function. Okay, now we've got the menu. Okay, it's empty. We need to populate our menu function. So what we're going to do, basically, we know that as per our problem here, okay, we need to display 1, 2, and X. Okay, so this menu is of type character, and we know that it's going to return something. That's the output. It will return the user selection. So we have to also do a do while loop here. That will only exit when the user enters something, so that the menu can return it. Okay, so we can go ahead and create a variable. Okay, the same variable that is also defined into our main.c. This is a separate file, okay? So we create a variable. Now, if I come down here, I'm going to say return select, okay? So this is the variable that the menu function is going to return. So when the menu function return that, we are going to store it here, and that is our exit condition also. If this is going to be equal to x, then we're going to exit. If it's not, then we continue. Okay, now, but here inside the LM317.c on the menu function, we basically also need these conditions. Okay, the conditions that are going to make us exit that loop and return the variable. Okay, so let's go ahead and create our do while loop here as well. So we got to do and while. So now in the while, what are we going to do then? Now we know that according to our problem, we must have option 1, 2, and x. So which means we only going to exit this do while loop when the user select either 1, 2, or x. So that basically means if the user selection is none of those 1, 2, and x, then we have to continue doing our loop. So I'm going to say do while what? While select, okay? Because that's what the user is going to be entering. While select is not equal to character 1, okay? And select is not equal to character 2, and select is not equal to x. Okay, so now I can also just put these two upper so that we can also capture when the user enter a small case x or a capital letter x. Okay, so these are my exit condition for my do while loop. Before I do that, I'm going to clear the buffer by calling system, okay, and then pass the parameter CLS. That is going to clear the buffer and something on the console. Okay, now we are ready to start writing our menu. Now, we're going to write the menu obviously with a printf function. Now, we know that with printf function, we can use a bunch of / and for new line, okay? That's basically, and then we can use tabs to so that we can position. So I can write here LM317 calculation. Right now, if I print, I should be able to get something on the screen, unless if there is a problem into this code. Well, there are problems. There are indeed problem into this code. We've got one error and a couple of warnings, quite many warnings. So the first error is obviously this one. It says expect file name. What is wrong here? Oh, there we go. We're missing a double quote there. Okay. So what is another problem? Let's run and see where else we fall. Okay, token. Okay, we're missing a semicolon here. So that's what you do. You write program, there are errors, you fix them, small type of errors. You can get them easily, but the main thing will be to get your program working as expected. Compile a problem, you can always find them and fix them very easily. So now when I run this again, obviously it will pop up. And I'm getting LM317 calculations, and it is blinking the whole time. Now to stabilize that, I need to add something here. Okay, I need to add something that is going to basically the scanf or the get car, so that I can actually pause a program so that I can wait the user input. So I'm gonna say select. Okay, my variable is equal to get car, like that. Okay, so now when I run it, it's not going to be blinking again. It's going to be stable on my screen, as you can see there. Now, there is a problem here is I'm using \right n for new line and backslash T for the new tab. But now this is not very pretty because every time I have to basically navigate into my console application. Now to do that, to change that, I'm going to use another function, which is a window built-in function to navigate into my console application. Okay, so I'm gonna write a function quickly. I'm going to call this function void go to xy. So basically this function is going to allow me to navigate into my console window here. So when I run the go to xy, basically you can see this is a x coordinate and that's a y coordinate, so which means I can navigate anywhere I want to with this function. Okay, now this function takes parameters. Okay, it takes parameters of type integer, so it's int x and then int y, which are my coordinate for my function. Now the function use coordinates, so I'm going to declare two variables, code that x is equal to x, and another variable, code that y is equal to y. Now I'm going to call a Windows function here that set the console wherever I want it into my console application window. So it's window set console cursor, okay, position. And then into this function, I need to pass a few parameters. So the parameter that I'm going to pass here is I need to get where my cursor is. So that is with the function get std, which means a standard handle. Okay. And then into this function, I need to pass a parameter std output, okay, underscore handle. And then the last parameter is I need to pass the coordinate where I want to be, whether it's a x or a y coordinate. Okay, now this function is all set. There is only one thing that is missing here. I need to basically define this coordinate as a global variable. So I'm going to come here and I'm going to say global variables. Okay, so this is where I'm going to define my global variable. Then I'm going to say code is equal to, my coordinate will start with 0, 0. Okay, so this space here is too much. Don't want to be creating problem, but solving problem. Okay, now the only remaining things here is basically the function prototype. Okay, so I'm going to copy this function and I'm going to place it into my header file here under the function prototype. But obviously this is not really necessary if I'm not going to be calling it from the main. If I'm only calling it from here, I can basically just put my function prototype here. All right, now we've got the function prototype done. Now we can basically go ahead and try to run it, but before I run it, I'm going to call it first. So I'm going to say go to xy. Okay, then I'm going to pass the coordinate where I want to be on the screen. So let's say I pass coordinate for x, I want to be 10 places, and then for y, I want to be 5 places. And then I want to see where this is going to take me. So I'm going to remove all these backslash and the new tab here. Okay, now let's go ahead and see where this is putting us onto the screen if there are no errors. So I run this. Obviously there is an error. What's going on here? Unknown name. Okay, the code name, the code variable here, this is defined into the Windows. Okay, this is defined into the Windows header file. So I have to include the Windows header file into my program. So I will say include Windows, okay, .h. Right, now let's go ahead and try running it again. See if we're going to get an error. Okay, it seems like he is a little bit satisfied, but he's compiling. There we go. So you can see that we've successfully placed LM317 calculations on our screen. But now you can see this mean here, this is an X variable. Okay, so it's 10 places, and this is 5 for the Y variable. Now I'm going to leave it at 5, okay, but I'm going to push it a little bit on the center, so I'm going to change my X variable to something like 20, okay, so it can push it a little bit further in the center of my console application window. All right, here we go. So you can see that it did move. It was somewhere here, it's moved there. So I can now go ahead and start populating my menu here. So I'm going to copy those files. So I'm going to do a lot of copies here now. And this is going to be, now I'm going to move a new line. So I'm going to stay on 20 on the same X coordinate, but I have to move to a new line. So I have to step down or step up with the X coordinate. So here I'm going to call another printf. Okay, now in this printf I'm just going to underline this LM317 calculations. Okay, then I'm gonna copy again, and this time around I'm going to step down 2 lines. Okay, and I'm going to write another statement, printf, and in this statement I'm going to now put the first options here. So the first option we have, let's call it fixed output voltage. Okay, so as we discussed, you can have a fixed output voltage by selecting a specific value of a resistor. You can see here we've got what, 5.4. Now this 5.4 is as a result of us tuning the potentiometer value. But now if we replace the potentiometer value now with a value that is now sitting there on the potentiometer, we place it right here, we're going to get the 5.4. So that is the fixed value output regulator. Then the next option here, so we have to go down again. I'm going to go down 2 lines. Okay, then the first option, let me just copy here. Then the second option, I'm going to replace here with 2. Then I'm going to say variable. Okay, variable or adjustable, so it's going to be the same thing. Variable output voltage. Okay, so now the third option, we know that, okay, I don't want to copy that, I need to copy this one here indeed. Okay, and we want to jump again 2 lines. Okay, and we need to write another line here, and that will be option X, and option X stands for what? Exit program. Okay, so if you select X, then you exit the program. Now we sort of have some kind of a menu going on, and I am going to copy another line, right? So this one, I'm gonna make it, let's make it 15. Okay, so we make it 15, and then here we call again another printf, and in this printf I'm going to write, please make a selection. So this is where we are basically just asking the user to make a selection. Okay, so the user need to make a selection. Say, please make your selection. Okay, so the user is going to make a selection there, and select variable here will be getting the character from the user as the user entered it. Okay, so now let's try again, run this, and see where we're going to be at. Okay, now you can see we've got some kind of menu going on here. LM317 calculation. So we got so we got option 1, fixed output voltage, option 2, variable output voltage, and X is for exit program. then we are please make your selection. Now if I make a selection of 1, right, so I choose 1 and then you see nothing happened, so I just chose 1 because I'm not handling 1, okay, but you can see that my menu kind of did exit, okay. I did exit my menu, right? I did exit, but because I'm not handling 1, so I return back there, okay? So I return back. So what's going to happen here? So what is happening here is when we enter either 1, 2, or X, right? So we are meeting our exit condition, right? So because this thing runs so long as 1, 2, or X is not entered. So when we enter it, we exit. So we return select, right? Select is then return, and then we catching it here, okay? Then this here will only exit this loop when it sees a X. So when it sees a 1, say, well, 1 is not an exit condition for me, so it stays in this loop. So it stays in here. Then what happens is we display the menu again. So that's why you're seeing that blink. Now what happened is, now what will happen when you enter a X, okay? So let's see when I enter, okay, not enter a X or anything else, but let's say I enter a X, okay? Let's see what's going to happen, right? You see now when I enter a X, the program actually have exit, okay? The program just exited because I've entered X, okay? I've entered X and then I've exit. Return process, because X is the exit condition for this loop, right? Now what will happen if I enter something none other than X, right? Let me just maybe enter some debris here, okay? Then you can see now my program went sort of in a hiccup there because he didn't know what to do with that. Didn't know what to do with that, okay? But eventually he came back, okay? Eventually we came back into the menu. Why? Because we didn't exit. We are still in here, okay? So we came back, but he didn't know what to handle it, okay? So because it's not part of this process here, so what we have to do here is we must include a condition that can check if someone enters some random character or nonsense on our screen. We must handle it, okay? So I'm going to add an if statement here. So I'm going to say if, okay? And inside this if statement here, I'm going to say, well, if the user selection is none of these, okay? So I think basically I can just let me just take all of these, right? So if select, okay, so if select here, if select here is none of these, okay, if select here is none of these. So now imagine here there is a problem here because select here could be a small letter, right, X, and I won't be able to capture it because I'm doing 2 upper here. So I'm going to just change these 2 upper, okay? I'm gonna put the 2 upper here where I'm getting the character. So I'm gonna say 2 upper there. So I'm gonna say 2 upper there, and this one here I'm just going to leave it to be select, just like that. Okay, that way I can also get the capital letter here if the user enters small letter, right? So now if select is not 1, is not 2, is not X, okay, right? So now I am not going to exit the loop, right? But I need to tell the user that, well, you've entered something wrong, okay? Please choose what is on your menu. So what I'm gonna just say system, okay, just to clear the buffer with CLS, okay? Now after clearing the buffer, I'm just going to print something on my screen, okay? So I'm gonna say print F, but where do I want to print this thing? I want to print this thing on, I want to print this thing on the center of my screen. So let's first write what we want to print. I will say you have entered an invalid selection, okay? And I want to display this for a few seconds, so I'm going to say sleep, okay? I'll call the sleep function. I'm going to pass 2 seconds, Okay, so we want to display this message on the screen for 2 seconds. But now, because I'm going to clear the screen, so I need to specify where I want to display these things. So I'm going to take my goTo function and I'm just going to place it here so that I can be somewhere on the center of the screen. Okay, let's maybe make this one a 10. Let's give it a shot and let's see what we get. Well, unexpected error. Okay, well, we are missing a semicolon there. Let's give it another try and see if this time around we going to be successful. Okay, there we go. So this time around we were successful. Okay, now let me enter my gibberish here and hit enter. Now you can see you have entered an invalid selection. Well, it's coming back. Okay, it is coming back. There is something is coming back. So the reason why it is coming back is what I've entered is still sitting somewhere in the buffer. So I think I need to clear it again so that I don't come back. Okay, so now it's done. Okay, so now this has to do with some buffer holding what I've just entered. And since it is still there, now I keep on executing and coming back to the same thing. But we need to sort that out. Now, but obviously we can see that we are able to handle a wrong input from the user. Now, before we can handle that particular problem, okay, let's first start handling our options, okay? So, because first of all, when we are entering, okay, a number, we should be able to process it because we have two options here as per our flow chart. Okay, so we have option 1, okay, not our flow chart problem statement here. We got option 1 and option 2. Now let's first handle all these options, okay, and then we'll see if we can come back and solve this problem. So if I enter 1, okay, now it's telling me I've entered an invalid selection. Okay, so you can see there is an issue there. But let's first handle it and see what's going to happen, because what we are entering with the user input there is coming here. Okay, this is where it's coming, and when there is nothing to handle it, then we return there. So in order to handle this, let's create a switch case, okay, a switch statement. So I'm also going to just add a system clear here, like a buffer clearance, okay, it always helps. And then I'm going to create a switch statement here. Now in this switch statement, obviously we are switching the variable select that we are obviously we're collecting it here as a return from the menu function. Now inside here I'm going to create all my cases. So case 1, okay, now case 1 here we want to do the fixed calculations. Okay, so case 1, what are we doing in case 1? I'm gonna put a comment. I'm going to say fix output, right? And in here I need a function. Okay, I need a function that is going to perform that fixed calculation. So I'm going to say fixed output, and then we have to break. Then case 2. Now case 2 is going to be variable output. Okay, and in case 2 we also need a function, so we're gonna call that function variable underscore output. Give your function descriptive name so that you know exactly we start thinking too much what this function does. And then the final one, case X. Okay, so case X here is where we handling the exit. Okay, so it's exit program. Now what are you going to do in the exit program? So here you basically just want to print also a message. So I'm also just going to say printf. Okay, we call the printf function, and in this printf function you just enter a message that will basically just indicate the program have exited successfully. So we can just say program successfully. Okay, something like this. Program exited successfully, and we want to display this message also for something like 2 seconds. Okay, for something like 2 seconds, and then the program is going to quit, and then we're gonna break there. Then we can also have a default case. Now default case here, really you may or may not use a default case, but it's a switch case. You must always have a default case, and inside the default case here you can basically place whatever you want to do here. Place your code. Okay, so you can place your code for the default case in there, but we are only dealing with these 3 cases. Okay, so now we have at least we are able to handle. But now if we run the program, obviously let's not enter 1 or 2, because we're going to have problems. We're going to have problem if we enter 1 or 2, because we don't have this function yet. These functions, they are not defined yet, but we will be able to print a message on our screen. But I'm not going to run this because the 2 functions are also not defined yet. It's going to give problems. So I'm going to come back into here, my library, okay, and I will copy this, okay, and I'm going to basically, okay, I have to paste this also here, and this is what we call this function. So we're gonna say cursor. This is a cursor navigation. Okay, input parameters, yes, x and y, coordinate. Okay, and then its output basically nothing, because it just takes you where you want to be. Okay, I'm gonna leave this function to be right at the end, and then another function. This function now is going to be fixed output voltage. Fixed output voltage. Now the input for this function, yes, this function is going to receive some variable, but let's leave that for now and just basically create the function. Now this function is basically just going to do a calculation for a fixed voltage. Okay, so when the user called fixed voltage, this function is going to ask the user what voltage do you want. Now if you want 5 volt, you're just going to enter 5 volt, and this function is going to go through steps and tell you, well, for a 5 volt your value of R1 should be this particular resistor for your R1, so that you can get a 5 or a 6 volt. Okay, so I'm going to just make it a void, because it's not going to return anything. The calculation will be performed by other function. So we're gonna say void fixed. Okay, so we already named this function here, so let me just copy that so that we do not make mistake of getting another name in there. Okay, so it's going to be a fixed output, and this function is not going to have any return. So I'm going to just copy it. Obviously it's a void function. Okay, so, and I will place a function prototype here. Okay, now we need another function. Let's come back into our library here, and I'm going to basically just copy everything, and this is going to be variable output voltage. Variable output voltage, and I think we can just change there with variable. Then we have to copy this as well, and then make a function prototype variable. Now just make sure that it is indeed the same name. Okay, variable output. Right, now we are inside a fixed output and we have to declare the variable. Obviously here the user wants a fixed voltage. So if the user say, well, I want 5 volt or I want 3.3 volts, so we need a variable. So I'm going to just say variable declaration. It's important to always put comment, and in the variable declaration we're going to declare a variable of type float, and we're going to call this voltage. Okay, so now it's important, okay, because a voltage that the user can want could be a 3.2, 3.1 or 5.2, 5.1, so which means it's a float variable. If you make it integer, you're going to lose data. Right, so now that we've got our variable, then we can basically just print a statement asking the user to enter the voltage that he wants, okay, on the output of his LM317. So I'm going to just write printf, and here I'm going to write, please enter the desired output voltage. Okay, so please enter the desired output voltage. Now this is a question that we are asking to the user, that he need to enter the required output voltage. Now I need to also go to a go-to function here, so I'm going to select, this one is good because I want to be somewhere in the middle of the screen. Okay, go to XY, please enter the desired output voltage. Okay, and the way we're going to capture this desired output voltage here is by doing the scanf function. Okay, so I'm going to call my scanf function. So here I'm just going to enter my parameters, %f, okay, format specifier for float. Okay, and here I'm going to then reference it to my variable the way I define, which is voltage. Okay, voltage. Why am I always getting it wrong? Voltage. All right, now that we have a voltage, so what are we going to do with this voltage? Now remember, we are calculating the resistance. Okay, we are calculating the resistance that's going to give us a particular voltage. So if I swing this here, now you can see if I swing this is 3.28 volt. Okay, so 3.28 volt correspond to a voltage that I just swing with my potentiometer. So if I disconnect, I will be able to measure and know what resistance it is. Okay, and if I replace that resistance, I should be able to get 3.27. Okay, so we are calculating the resistance. So now we need to develop the equation for that resistor. So I'm going to create another variable here. Okay, so I'm going to call this variable basically R2. Okay, because that's a resistance that we need to calculate. So that is R2 will be fixed. So I'm going to call it R2. Now, the equation that I need to develop here is going to be calculating the value of R2. So if I say here, R2 is equal to, now what is R2 is going to be equal to? So I need to develop that function, that equation. Okay, so if we look here, here is the output voltage function that we have. This is the output voltage equation for the LM317. Now, if we want R2 out of this equation, that basically means we need to make R2 the subject of this equation so that we can calculate R2 based on what the input or the output voltage is. We know what the reference is, that is 1,25, and we know what I adjust is. I adjust is going to be 50 microamps, and R1 240 ohm, but in my circuit I indicated earlier that my R1 is 220 ohm, so we can leave our R1 to be 220 ohm, and then we can calculate R2 based on what the user wants. Okay, so now to do that, I'm going to have to develop now this equation. So let's go ahead and develop our equation. So here I am. So R1, so we know that V out, okay? So V out is equal to Vref, okay? So bear with me while we do this mathematics here, is equal to Vref, okay, times 1 plus R2 divided by R1, okay, close bracket, plus I adjust, okay, so this is I adjust, times R2. Now this is the output equation, okay, the transfer function or the equation for V out. Now we want to make R2 the subject of this formula. Alright, so I'm going to, first of all, I'm going to distribute the Vref into the equation there. So I have V out. Now we know that Vref is equal to 1.25. Okay, so if I distribute it, so I'm going to have 1.25 plus 1.25 divided by R1. Now R1, I've said that in my circuit, R1 is 220 ohm. So I'm going to replace here with 220 ohm, and this is going to be R2. Remember, we're trying to calculate R2 here, okay? Then it's going to be plus I adjust times R2. Now we know that I adjust is said to be 50 microamps. So that is 50 times 10 to the power what? Minus 6. And this is going to be R2, okay? So this is my equation. Now, I'm going to divide this 1.25 divided by 220, okay? So 1.25 divided by 220, okay? So I'm going to get V out is equal to 1.25 plus 5.68, okay, times 10 to the power minus 3, and this is going to be R2 plus 50, so I'm just repeating the same thing here, 10 to the power minus 6, R2. Okay, so now we can see that those two equations here, these two variables here, they've got what? R2 in common. So which means we can basically factor the value of R2 here. So if we factor R2, we're going to have also here V out 1.25 plus R2, okay? Then we have to make the addition of this 5.68 plus the 50. So I'm going to have 5.68 times 10 to the power minus 3 plus 50 10 to the power minus 6. Okay, and when I make that sum, I'm getting 5.73, okay, 10 to the power minus 3, something like this. Now this basically means if we balance things, okay, if we move things to the other side, so we basically going to have V out here minus the 125 here, 1.25, because it's move on the other side of the equation, okay, and then we're gonna have R2, okay, 573, 10 to the power minus 3, something like this. Now we can make R2 the subject of the formula, so R2 will be equal to V out, okay, V out minus 1.25 divided by 5.73, 10 to the power minus 3. Okay, so this is your equation. This is your equation. Okay, that is your equation for R2. So here, what we just did here now is, if you have R1 here to be equal to 220 ohm, okay, and you said, well, I want my output voltage to be 5 volt. So you put a 5 volt here, and then you compute this equation, then you're going to get a value of what? R2. So basically, what does mean? If I say I want 5 volt, then I'm going to say 5 minus 1,25 divided by 5.73 times 10 to the power minus 3. Okay, now if I compute this, I'm getting a value, right? I'm getting an answer here. If you guys can see, if you can see there, I'm getting an answer of 654 ohm. Okay, so that basically 654 ohm. So I can round it because you want to find a 654 ohm resistor, so you can round it to like 660 ohm or 640 ohm to a standard resistor value that you can find. So which means if I take a 660 ohm or a 680, 670 and place it in here, I'm going to get a voltage that is going to be near that 5 volt that I just calculated. Now let's test our equation here before we can use it into our code. So what I'm going to do is I'm going to find a 654 ohm or 660 ohm resistance, and I'm going to place it into my circuit here and see what will be the output voltage. Okay guys, so I found a resistor value, but it is not 654, it's 674 ohm. Okay, so I'm going to place it right down there, and I'm going to measure it. Just check on the display of the multimeter here, so you can see we're getting 0.674 ohm. So 0.674 ohm does mean that it is 670 ohm. So it's a standard value. So now we expect that we're going to get a voltage that's going to be a little bit more or less than 5 volt, because we are not getting exactly the same resistance value. So what I'm going to do is I'm going to disconnect my potentiometer. Okay, so as I disconnect it, and then I'm going to place this fixed value right here. Right now, you see, look at it, we're getting 5.27 volt. There it is on your screen. We're getting 5.2 volt. So which basically means here that our equation here of R2 is true, is working. So for every fixed value that you want, it's going to give you the resistor that is needed to get your LM317 correct voltage on the output. So we can go ahead and develop this equation into our C programming code.